According to the CDC, 780 million people worldwide do not have access to clean water. The company Aquifer is dedicated to bringing clean water to rural communities around the world. Groundwater is a sustainable solution that provides clean drinking water to these communities. Aquifer is developing the Borelite drill in order to utilize this resource. This drill is designed as a lightweight, long-lasting cable-tool drill that fits on the back of a utility trailer. The Borelite design allows the drill to travel to a remote location where conventional auger drills cannot easily access. The Borelite drill offers a simple, portable, and inexpensive solution to the water crisis in developing countries. The drill can be maintained and operated by a person with minimal training. There is no documentation for the current Borelite drill. The Bray department was asked to form a team of students that could reverse engineer the current drill while making design improvements and creating build plans for manufacturing. The department divided the drill into 3 teams, the upper, middle, and lower Borelite group, who were then given a budget of $30,000. The lower Borelite team's goal was to build a robust, low-cost, low-tech trailer that will support the drilling boom and mechanical components. Design a trailer to fit 3 into a standard 40-foot shipping container. Design the trailer with a desirable tongue weight for a Toyota Hilux truck. Create a hitching system that can be removed and replaced easily. Develop detailed build plans for production. Work together with the 2 Borelite teams. And most importantly, deliver clean water to people in need.
The trailer frame was constructed using both 4 and 3-inch square tubing for ease of fabrication.
In this stage, you can see us doing the final welds and preps to the tongue of the trailer. This process required us to align the tongue with the frame in order to have everything in line with each other. After looking at the total length of the trailer, we realized we had to shorten the tongue. Shortening the tongue required a handheld grinder to cut through the beam of steel because a bandsaw cannot be used to cut the trailer tongue with it fully built.
the axles and the leaf springs could be mounted to the trailer, the hangers had to be welded onto the frame. The hangers were welded on using the dual shield welder, and they were spaced by putting the leaves inside the hangers, mocking up the axles, making sure the axles were square, and then tacking the hangers and then welding the hangers. As you can see in the video, each hanger was welded at different points, and we left space before we welded the hangers on all the way, just to make sure that the frame didn't warp. Once the hangers were welded to the frame, the leaf springs and axles could be mounted to the trailer. This portion of the video is showing the leaf springs and then the axles being mounted to the trailer. And then after this was all complete, the axles were measured to make sure that they were still square to the tongue. Once the main portion of the trailer was complete and we had a rolling chassis, we started to build the railing.
Once the trailer chassis was rolling, we were able to incorporate the middle portion of the Borelite trailer into the trailer frame. With tolerances less than 1/8 inch, we were able to gently maneuver the middle frame into position.
The jacks were mounted to the trailer by welding the jacks perpendicular to the 3.5 inch tubing. This tubing then slid into the 4 inch tubing of the frame, and which allowed us to extend the jacks during operation. The first part of testing required us to make sure that the lights were working properly. In this video you can see that the brake lights and both turn signals and running lights were operational before we took the trailer out to be tested in the field. To simulate the operating conditions where this trailer will be located, we decided to take the trailer to an isolated location for testing. Another important part of testing was making sure the trailer can handle off-road and high-speed conditions. Based off this video, you can see that the trailer handled remarkably well and was an improvement on the previous trailer design. In this portion of the video, the mast of the trailer is being raised to the drilling height. As you may have noticed, the truck has to be disconnected so that the mast can be fully extended before it's raised up. During design, this brought up some worry that the speed and momentum of the mast going up would make the trailer pop a wheelie. Nonetheless, during testing, we decided to raise the mast slowly, and we found that there was no issue with momentum adjusting the position of the trailer.